This is Lab 21, Example 3. We want to find some information about our quadratic function. F of x is equal to 3x squared plus 12x plus 9. The first thing we want to do is find the vertex. So a vertex is a point in the form x, y. We want to find an x value and a y value. Our x value is given by the formula negative b divided by 2a. So if we plug in, our b is 12, so we have negative 12 divided by 2, and our a is 3. So this is negative 12 divided by 2 times 3, which is 6, and negative 12 divided by 6 is negative 2. So now that we have our x value, which is negative 2, we're going to plug negative 2 into our x's here to find what our y value is. So we have f of negative 2 is equal to 3 times negative 2 squared plus 12 times negative 2 plus 9. And if you plug that all into a calculator, you'll find that this is negative 3. So our vertex is the point negative 2, negative 3. Now that we know our vertex, we're actually going to put our function up here into vertex, or also called shifted form. This will help us later. So vertex or shifted form is when we have f of x is equal to a times x minus h squared plus k, where a is our leading coefficient and hk is our vertex. So a is our leading coefficient. It's going to be 3. So I'm just going to write that there. A is equal to 3 as it is our leading coefficient. So f of x is equal to 3 times x minus our h value, which our h value is our negative 2. This is minus negative 2 squared plus k, which our k is negative 3. So we can rewrite this a little prettier. This is 3 times x plus 2 squared minus 3. And we will use this later on to look at transformations, among other things. So now that we found our vertex, we're going to ask, does the parabola open up or down? And we want to sketch the graph. So if our leading coefficient a is greater than 0, or in other words, if it is positive, then the parabola will open up. And if a is less than 0, if it's negative, then it will open down. So our a, our leading coefficient, was 3. So we have a is equal to 3. 3 is greater than 0. It's a positive number. So we know that our parabola will open upwards. So let's draw a little graph over here. We know that our vertex was at the point negative 2 and negative 3. So it was right here. And we know that it opens up. So this may not be completely accurate, but it'll look something like this, maybe. So we can use this to look at our domain. The domain of any quadratic function is just going to be all real numbers, negative infinity to positive infinity. No matter where you draw horizontal lines on the graph for each x value, if you travel up or down, you will eventually be able to touch your graph. Our range, if we go from bottom to top, if we draw horizontal lines over here, we'll never touch the function. But if we go to negative 3, we will in fact touch the function, and we will touch the function at any y value above negative 3 to positive infinity. So our range goes from including the value of negative 3, so bracket, closed bracket, to positive infinity is what our y values will include. Moving on. We have a little question here. To graph y is equal to f of x, how should we shift the graph of 3x squared? So this is essentially asking, if we have the parent graph of y is equal to 3x squared, how do we get our child, which is the graph we are technically caring about, which is back to when we had put it into shifted form. which is y is equal to 3 times x plus 2 squared minus 3. So it's asking how would we move our parent graph to get our child graph. So, moving from left to right, we have 3x squared. We'll notice first one of the changes is instead of x squared, we have x plus 2 squared. We have this plus 2 with our x, and if it's with our x, we're talking about horizontal movement. And if we are adding 2, we are going to the left 2 places. So we are moving left 2 because we are adding 2 to x. And we'll also notice that if we ignore this first change, we have 3x squared, and then we subtract 3. Now if we subtract 3 from our function, we are moving down 3 spaces. So if we added 3, we'd move up 3 spaces. So we're talking about vertical change. So because we're moving down, we are going, almost wrote up there, we are going down -3. So these are our shifts. So another thing they want to ask is where is f of x increasing and where is it decreasing? So we're going to bring back our little picture here. So we'll notice first, if we start from left to right, we're going to notice that our slope is a downward slope, and so we are actually decreasing. We are decreasing until x is -2, which is where our vertex is. And then after we pass x is -2 and we're moving still from left to right, we start increasing. Our slope is increasing. It's a positive slope. So we are going to write decreasing first. We are decreasing from -infinity until x is -2. So we are decreasing from -infinity to -2, and we are increasing from -2 to positive infinity. So from -2 to positive infinity on our x-axis, we are increasing. The last thing we want to do is we want to find the intercepts. So first I'm going to find the y-intercept. The y-intercept is when x is equal to 0. So using our original function, where we have 3x squared plus 12x plus 9, I'm going to substitute 0 in for each x. So we have f of 0 is equal to 3 times 0 squared plus 12 times 0 plus 9. This term goes to 0, this term goes to 0. So f of 0 is just ending up to be 9, which means our y-intercept is going to be the point 0, 9. Box that. Now we need to find the x-intercepts. The x-intercepts are when y is equal to 0. So we're going to set our f of x is equal to 0 and then solve for our x. So we have 0 is equal to 3x squared plus 12x plus 9. We can either factor this or put it in the quadratic equation. Because I see a greatest common factor of 3 that I can factor out, I'm going to factor it. So we have 0 is equal to 3. So factoring out 3 from all of this, we are left with x squared plus 4x, I forgot the x up here, plus 3. And we can divide both sides by 3. 0 divided by 3 is just 0. So this is essentially just 0 is equal to x squared plus 4x plus 3. And now we can factor this 1, which is a lot easier because our a is 1. So if we factor this, we get x plus 3 times x plus 1. We factor that. And if we set each of these equal to 0, we have x plus 3 is equal to 0. And if we solve this, we subtract 3 on both sides, we get x is equal to -3. And we have x plus 1 is equal to 0. If we solve that for x, we get x is equal to -1. So we have the x-intercepts at the points -3, 0 and -1, 0. And that's the last information they ask of us.